Okay, lesson 30, they say a little history, but it goes back into stuff you've already seen and experienced. So I'm going to fly through this fairly quickly. We introduced this thing by talking about the imaginary number system, and there's a great YouTube video to go to and watch and see how this becomes a parabola that is a three-dimensional parabola that introduces uh, imaginary numbers. We know if we set this equal to 0, right, and we get x squared is equal to negative 1, therefore um, x is equal to plus or minus the square root of negative 1, which has to be plus or minus I. That creates a whole new dimension, which we've talked about already to a certain degree. All right. Um, I suggest you stop and fill this in. I'm not going to take a lot of time on this. I actually like uh, this diagram better. That's not in your book. It gives you examples. The entire world, or the entire Venn diagram, including imaginary and real numbers, is called our complex number system. And it's broken down as is. But again, I'm going to let you take a look at that. If you should be familiar with all those number systems. And again, hitting all that stuff all over again. One of the things that we talked about in this that we didn't teach before is the discriminant. Don't worry about it. I'm not going to test you on it, but it's beneficial to pay attention to, if under the radical in the quadratic formula, if that number is greater than 0, then you're going to have two real solutions. If that number under the radical is equal to 0, then you're only going to have one real solution. If by chance this turns out to be negative, you know you're going to have an imaginary number or two complex solutions. Notice that these always come in pairs. You will never just have one. They come in pairs. That will be important later. Um, just stick in the back of your head there. All right, lesson 31, operations with complex numbers. And again, this isn't going to be too bad to start with. They start about just talking about adding. Well, obviously the I is acting like a variable, so 3 plus 7 is 10. 4 minus 20 is negative 16i. Adding and subtracting is pretty easy. Um, Subtraction, you might want to consider distributing. 3 plus 4i minus 7 plus 20i if you want. That becomes 3 minus 7 is negative 4. Um, 4i plus 20i is plus 24i. How you think that through is up to you. Make sure you pay attention to that negative sign. It has to be distributed to both terms. If you don't do that, you're going to end up with some mistakes. This is where we get a little bit crazy. And I'm going to suggest we just simply go back to our distributive property, right? This says 1 times 1 minus 2i plus 2i times 1 minus 2i. That's going to give me 1 minus 2i plus 2i. And then this goes plus positive times negative is negative 4i squared. Now we're not done yet. Notice the plus and minus. This is a difference of squares. It's a difference of squares. That means that the middle term here is going to go away. Why? Because they subtract out. This I squared automatically becomes negative 1. Negative 1 times negative 4 becomes 1 plus 4, or our answer is 5. And notice that the difference of squares with an I squared becomes a whole number or a real number. All right. But I'm gonna again gloss over that. That's a distributive. Getting back to your double distributive property, which I think you guys got pretty good at. I want us to verify uh, that um, this and this are solutions to this. They want us to plug those in. I don't know if you really need to do all that, but I'll do that for you and show you the work. Okay, so all I did is go through and multiply this out, plug it in, multiply it out. Notice that the 4i squared, the I squared becomes -1. So all that did is change its sign, and get in the habit of circling those so that you know to change the sign. And clearly all this does equal 0, so it does verify. I'm not going to verify the second one. I think you're going to trust me on that for the uh, sake of time here. All right, so go ahead and stop the video. Why don't you practice these and see how you do? Okay, so again, circle the I squared so you know what's going on. That should have been x squared plus 1. Hopefully you're starting to recognize the difference of squares, so I didn't work it out. It's just x squared plus 25. Um, this one is a little bit more tricky. I went ahead and distributed here, so we only had one set of parentheses. So we have a triple distributive property. Crossing out the like terms, and we ended up with x squared minus 4x plus 5. So these are asking us to factor. This is interesting. If I'm factoring, it's almost easier to solve. Um, let's go ahead and just find out what it is, and then we'll put it in factored form. You guys decide what you like better, but x squared equals -9, so therefore x equals plus or minus the square root of -9, which equals plus or minus 3i. If I were to continue here and put this in factored form, wouldn't that be x minus 3i, x plus 3i? Inside the parentheses, the sign switch, so the plus becomes minus, the minus becomes plus if you're worried about that. So this is going to be x minus I root 5 and x plus I root 5. Hopefully you're getting the hang of that and it makes a little bit of sense. Otherwise, solve it. Now they're getting into the fun stuff where they're asking us to actually construct an equation. So remember, based on what we just learned, my equation f of x could be equal to x plus 2 times x minus 3. This is the zero product property, isn't it? X plus 4i times x minus 4i. And again, they would like you to write it in standard form, which means you're going to have to multiply this thing out. So I'm going to pause it so you guys don't have to watch the whole thing. You'll see it when it's done. Okay, these get a little bit entailed and fun. I skipped a couple of steps here, but I think you can follow it. Pay attention to your signs down here. Collecting like terms. Make sure you're getting your x squareds in their appropriate place. Take a look, see if you can get it figured out. These go fairly quick. Given 3i, or 3 plus I, and 1 plus 3i, so yes, they're asking us to add those and graph all three of them. So I'm gonna go ahead and add. We can add those. That becomes 4 plus 4i. I'm gonna pause it so we can graph. Okay, so notice that the addition obviously is longer. This is your introduction to vectors without actually telling you these are vectors. When you take the vector and put them tip to end, notice the result is pretty cool. You get the resulting vector 4 plus 4i. Pretty cool. Explain what you discover if you draw a line segment from the origin to these. Well, I just did that for you. Um, like I said, that was the points themselves are here, but I drew the vectors in or the lines in. Don't sweat that stuff, you guys. It's not that big a deal. And then they ask you to do that again. I'm going to skip that and move on. Um, Adding two complex numbers is comparable to combining like terms, right? Remember, I squared is -1, and we're good to go. Good luck, you guys. Have fun.